Figure 2 shows a sketch of the curve C with equation y equals 2 minus 1 over x. X doesn't equal 0. The curve crosses the x-axis at the point A. Find the coordinates of A. Show that the equation of the normal to C at A can be written as 2x plus 8y minus 1 equals 0. The normal to C at A meets C again at the point B, as shown in figure 2. Find the coordinates of B. So I've got the question summarized here. So the first thing to do is find the coordinates of A, and that was when this curve cuts the x-axis, doesn't it, when y equals 0. So part A, y equals 0 gives, so is this equal to 0 then? 2 minus 1 over x equals 0. So move the 1 over x over, 2 equals 1 over x. Move this over, it flips the sign, and that tells us then, move the x up to be with the 2 in our mind's eye, and at the same time move the 2 down to be underneath the 1, so x is equal to a half. So when x is a half, y is 0, so A has coordinates then a half and 0. Find the coordinates of A, done. Show that the normal to C at A, so part B now. So B, y dashed is equal to, here's the equation. This is 2 minus x to the minus 1 in our mind's eye. The constant goes to 0. And then the minus 1 comes down to be with that minus to make a plus. 1 over x squared, isn't it, when we differentiate? So y dashed equals 1 over x squared at x equals a half then. Y dashed is equal to 1 over a half squared. A half squared is a quarter. 1 over a quarter is 4. So we can write that down straight away. So normal has gradient then. So normal is, well, it'll be y minus, it goes through the point A, so it's y minus a half is equal to the gradient of the normal times x minus the x, y minus the y value, which is 0. So let's put that in correctly. Is equal to the gradient of the normal times x minus the x coordinate at A, which is a half. The gradient of the normal, well, the gradient of the tangent is 4, so the gradient is minus 1 over 4, isn't it? So that's what we've got. Move the 4 up, so that implies then, so the 4 comes up to be with the y to make 4y is equal to, and run the minus through here, minus x plus a half. Multiply everything by 2. 8y is equal to minus 2x plus 1. So I've doubled everything through the entire equation. And that tells us then that 8y plus 2x, when we move it over, minus 1 equals 0. And what did we need to show? 2x plus 8y. So let's just move it around. So 2x then plus 8y minus 1 equals 0. So there's part B. Now we need to find out, this normal cuts C at B. Find the coordinates of B. So this normal cuts C at B. So the equation is y equals 2 minus 1 over x. And we've got this equation here. So let's put the y value in. So we get 2x plus 8y, which is 2 minus the 1 over x, isn't it? Minus 1 equals 0. So let's multiply through by x, 2x squared. Here we've got 16 as a number. Minus 1 is 15, so that'll be 15x. I'll write it down straight away. Then we've got minus 8 over x, which is just minus 8. So I did about 3 things in one there, because 2x squared, I've multiplied all the way through by x, it's everything. 2x squared then. Here, but the number is 16 minus 1 is 15, times that by x is 15x, and this is minus 8 over x, times that by x you get minus 8. So there's our quadratic then. x, it has to be 2x and x equals 0. We know one of the roots is, what was it, x is a half. Okay, so that would be a 1 here, wouldn't it? Yeah, it's a 1 and an 8 then, isn't it? And this will be a plus and a minus. So that tells us then x is equal to a half, as we said, for this one. And this one gives us x equals minus 8. So the x-coordinate is minus 8. So y equals, put minus 8 in, 2 minus 1 over minus 8. Put minus 8 in, 2 and an eighth. So b has coordinates then. Well, the x-coordinate is minus 8. And the y-coordinate is 2 and 1/8. And I think that was all that was required, wasn't it? Let's just have a look. Find the coordinates of B. Here's our picture. And it all looks okay, doesn't it?